The topic of this video is determining the x and y-intercepts of a function defined by y equals f of x when that relation is shown as a graph. When a relation is graphed, any point that is on the x-axis or on the y-axis or both is called an intercept. The relation does not have to cross the axis to create an intercept. If a point is on the x-axis, we call it an x-intercept. And if a point is on the y-axis, we call it a y-intercept. The origin, 0, 0, is both an x-intercept and a y-intercept at the same time. Finding intercepts from a graph is easy. Simply look for any points from the relation that are on the x-axis or y-axis, or both. Let's look at several examples. All right, example 1 is this graph here, shown in blue. This is a function. What are its x and y intercepts? Well, the first thing we want to do is find where does the blue curve intersect the y-axis. The blue curve intercepts the y-axis at this location, which we call the y-intercept, and it has a y value of -1. So we say the y-intercept is -1. All right, where does this same relation intersect the x-axis? Well, it intersects the x-axis at this location. So this tells us that the x-intercept is -2. Okay, let's move on to our next graph, which is this graph down here. All right, first we're going to look for the y-intercept. Where does the blue curve intersect the y-axis? Well, the blue and the black cross here. Therefore, the y-intercept is the y value of that point, which is -3. How about the x-axis? Where does our blue relation intersect the x-axis? Well, it does so right here. And therefore, we find that the x-intercept is -3. You might have noticed that I am pronouncing my words very crisply. There is a difference in math between the word intercept, which is what we are studying, and intersect. Intersect is where two things cross or have something in common. But intercept is a very special type of intersection where our relation is intersecting either the x-axis or the y-axis.